Hi, everybody. Welcome to Love Goes Live. My name is Mark Lubkowitz. I'm a molecular biology professor at St. Michael's College, and I've been making videos for my students, the St. Mike's community, and really for anyone else who might be interested in sciencey sort of stuff. And I got an email notification this morning from Science on a paper that just came out literally this morning, and it's going to get a lot of press. And so I spent a little time thinking about whether or not I wanted to cover it, because it is the sort of paper that is going to become a talking point across our society and culture and probably globally, and I'm not sure I want to wade into that. But I landed on, I'm an educator, and as always, my goal is really just to help people, or I hope to inspire people to evaluate the evidence themselves and to critically analyze the evidence themselves. So if you haven't already heard, and you'll hear shortly if you haven't, that the first paper has just been published in a very top-tier journal, and it's examining the ability of domestic animals, specifically in this case, cats and dogs, to get COVID-19. What I will say, just right up front, is that this paper does not address at all the ability of domestic animals to transmit it to their hosts, to you and me, or for you and me to give it to animals, right? That was not addressed at all. And then I'm gonna end on this statement, but I'll say it now, is please remember that science is both incremental and self-correcting. All right, incremental is that most of these studies, if you've been following the COVID-19 story, most of these studies don't answer all the questions, right? In fact, they're only partial answers, or even they lead to more questions, because science is incremental. The other thing is that science is self-corrective. This is the first study. And as you'll see, as with all studies, because it's incremental, it leaves a lot of questions. And so maybe it's reproducible, maybe it's not. Okay, without any further ado, let's actually look at some data. I'm gonna share my screen as I always do. Give me a second here, it's always a little clunky. All right, boom, there we go. And let me get a highlighter here. Perfect, laser pointer. All right, I had some people email me online and ask me, how do I actually get the papers that you're referencing? And so let me just go ahead and tell you, this DOI up here, you can just type this into any search engine and you'll pull up this paper. Or if you want, just type in the title and you'll do the same thing. Either way, that'll get you to this reference. So as I said, this paper just came out in Science this morning. It's a preprint that's been released. The hard copy isn't out yet. You can read the title, and they examine ferrets, cats, dogs, and pigs and chickens to look at susceptibility. And we're going to start off by looking at cats, because that's really the take-home message for this paper. So first question was, can cats get COVID-19? So they took a very small number of kittens. So they defined kittens as being under 100 days of age. And they took juvenile cats, which I think they were 6 to 9 months of age. And then what they did was they inoculated them with 100,000 infectious COVID-19 particles. Now, this is a really, really, really large inoculum size. And they actually used 2 different isolates of COVID-19. They used one environmental isolate that they got from the Wuhan market. So this is one that they literally just found on the surface. And then they used a second isolate that they got out of a human. So this is a clinical isolate out of a human. And they have data for both. The paper is filled with data. I'm just gonna show you the clinical isolate data. Okay, so take a message. The first experiment was you take either kittens or cats and you're going to blow 100,000 particles into their face. And then you're gonna wait a certain period of time and ask the question, do the cats get COVID-19? Right. This is a very busy figure, but I'm going to walk you through it. So first thing I want you to notice is that there's 2 cats in this study. Right? These are juvenile cats. These are kittens. 6 days PI. This is 6 days post-infection. Right? So this is 6 days after they gave them 100,000 particles. These cats have been sacrificed. So this is post-mortem. What they're measuring is viral RNA. So this is qPCR. So they're just asking the question, is viral DNA present in these organs or these tissues per gram, all right? The numbers here, this is the number of viral particles. 10 to the second is 100, 10 to the fourth is 10,000, 10 to the sixth is 1,000,000. The dotted line here, this is the bottom detectable limits for qPCR, so this means 0. So anything below this line was really undetectable. And then finally, these are all the tissues that were examined, right? So we have the nasal cavity, the soft palate, the tonsil, the trachea, various parts of the lung, small intestine, and so on. So here's what you want to notice. So everything above the line. So cat 1, cat 2. So in these 2 kittens, there was viral RNA was detectable. Notice though that it's not the same for each kitten. So kitten 2, if we look over here in the left lung, kitten 2 had viral RNA in the left lung, whereas kitten 1 did not. Neither of them had it in the small intestine. Okay, so the take-home message is that by this measure in this very small sample size in these 2 kittens, that after giving them a large inoculum, you could detect viral RNA. All right, so the next question that they asked was this. So using these same 2 cats again, these same 2 kittens, 1 and 2, this is 6 days post-infection. Once again, it was sacrificed. They asked the question, are there infectious viral particles? That's different than viral RNA. Okay, so viral RNA is just asking, is the viral RNA there? Not all of it gets packaged into an infectious particle. Now they're asking, are there infectious particles there? The units here, PFUs, these stands for plaque-forming units. And what they do is they take that gram of tissue, smash it up, and then they try to infect what are called vero cells. And then they look at how many vero cells were infected. All right. So this is the number of infectious viral particles per gram of tissue taken out of the cat. All right. So once again, we're looking at the nasal cavity, soft palate, tonsil, trachea, various parts of the lung, and so on. Remember, everything below this dotted line is a 0. So first thing you'll notice is that the 2 kittens, once again, didn't respond the same. So kitten 1 had quite a few, a little over 10,000 infectious viral particles in the nasal cavity. Kitten 2 had 0. Interesting enough, kitten 1 had 0 infectious viral particles on the tonsil, whereas kitten 2 had about 10,000. Okay, so take-home message, this figure shows that there are infectious viral particles post-mortem on these kitten organs. The numbers aren't super giant, you know, they're much smaller than 100,000, that's for sure. So the next question they asked, they said, okay, so if we took these kittens that we had given 100,000 viral particles to, and we put them into a small cage with an uninfected kitten, would the uninfected kitten get it? In other words, can one cat give it to another? All right, so let's actually look at the data. All right, so once again, another really busy figure here. So they are measuring viral RNA, so not infectious particles, just viral RNA. This first panel, these are the 3 cats that were all inoculated. So there's these are kittens, sorry. There's kitten 1, kitten 2, kitten 3, right? And we're now monitoring the number of viral particles per day. Notice by day 10, all 3 of them seem to have cleared their viral particles, right? Then these are the matching pairs. This is the kitten that's in the cage with them that was not inoculated. So notice on day 1, none of them are sick. Day 3, none of them are sick. Day 5, this one kitten here now has detectable viral particles. And by the way, they're detecting it in the feces. So remember, this kitten right here is in the cage with this kitten right here. And then on day 7, that goes up. Day 9, that goes up. So what this shows is that when you take a kitten that's uninfected and put it in a cage with an infected kitten, 1 out of the 3 got it. And then, of course, they followed up and asked the question, well, if they get it, they had to have made antibodies. So here's the 3 kittens that were inoculated. Once again, the dotted line means that that's non-detectable limit. And what they're measuring here is antibodies using optical density. All right. So the 3 cats that were inoculated all made antibodies. That's to be expected. The 3 kittens that were in the cage that were not infected, the one that got it made antibodies confirming that, yes, it did indeed get COVID-19. All right, next thing that this group asked was, well, if it looks like cats and kittens can get COVID-19 and they can give it to each other in a cage setting, what's that mean for other animals? So they looked at, this is first of all, really, really busy table. We can deconstruct it, it's not that complicated. They looked at dogs, they looked at pigs, chickens, and ducks. Right? They're gonna look at the throat and the rectum. And then they're gonna take swabs at day 2, 4, and 6 post-infection. The bottom number here, this is the number of animals that they initially inoculated. And then the 0 represents how many of them had detectable viral particles. So in throat swabs, none of the dogs had detectable viral particles or viral RNA. Then contacted, these are the other dogs that were put into the same cage that were inoculated. So they put 2 dogs in there that were inoculated. None of them had detectable viral particles. And then notice for pigs, chickens, and ducks, a lot of 0s. In fact, all you see through here 0s, which suggests, but certainly doesn't prove, that pigs, chickens, and ducks can't seem to get COVID-19, at least in this very small sample size. Now, what's interesting is when you look at the rectal swab, So notice that 2 out of the 5 dogs did have detectable COVID-19 in their rectum. And so they sacrificed one of those dogs and asked the question, can we detect the virus now in any other organ or in any organ period? And so this is a quote directly out of the paper. Viral RNA was not detected in any organs or tissues collected from this dog. So in half the dogs, grand total of 2, that had COVID-19 in their rectal swabs, the one that was sacrificed did not have any detectable COVID-19 in any of the organ systems. Okay. So I've been looking at this paper, not that long, it just came out this morning, but it's got me thinking about some of the caveats, like what are the things that I'm personally considering as I look at this data. The first thing is the large inoculation size. So remember, all the animals were challenged with 100,000 viral particles. That's a large challenge. That's the equivalent of me if I had COVID-19 sneezing into my dog's face. And I have no idea if that is a relevant inoculation size. I'm going to guess that it probably isn't. So it's just something I'm thinking about. The other thing is the relevance of the viruses in autopsy organs. So one of the things they looked at is they asked what organ systems or what tissues are actually shedding infectious particles, viral particles, and that was done on autopsies. And I guess the question I'm struggling with is, just because it's in, a certain on the tonsil, what percentage of those viral particles then actually make it out of the organism into the environment where they can then be infectious? I'm going to guess it's a tiny percentage, but I have no idea what that percentage is. So I'm really struggling with, like, yes, those organs were shedding infectious viral particles. How relevant is it? And then the persistence in cats. They had that one panel where they showed that in 10 days, the cats seemed to have cleared COVID-19, with the exception of one that died, that's sort of common. And so I think that really hasn't been addressed. And then I keep saying it over and over and over again, sample size, sample size, sample size. If you remember, all those panels had 2, 3, 4, or 5 animals. That is, by any scientific study, a tiny, tiny, tiny study. All right, and then I don't own cats, so I don't really know, but cats in a cage, snuggling with each other, is that realistic cat behavior? Is that something that ever happens? And then the thing that really wasn't examined, and remember, science is incremental, is cat to human or human to cat transmission. And I think at many levels, that's probably what we're most interested in, and that has not been addressed at all. Right, so I started with this, and I'm going to end with this. Remember, science is incremental, and as you can see from my personal list of caveats, there's a lot of questions that haven't been answered or addressed. In fact, in many ways, this study asks more questions or leaves more questions that it has answered. Science is also self-corrective. So I have no doubt that there are probably already in progress other groups examining this exact same question. I have no doubt that they will increase their sample size, and they may even use a different experimental design. And out of that self-correction, we will eventually land on some sort of public health suggestion. But I can tell you now, we are a long ways away from that. Okay, so that's all I got for you this morning. As always, don't take my word for it. Go download that paper, look at the data yourself, and start to critically analyze. This is Mark Lubkowitz from St. Michael's College, trying to rise from the ashes like the phoenix, and always trying to let crisis bring out the best in me. Have a great day.